Hi, have a good day to our panels, Dr. Idris bin Saad and Madam Rosnadia binti Bahsan. Let me introduce myself. My name is Angom Anak Michael. My supervisor name is IRTS Dr. Baljit Singh. My title project is Techno-economic analysis of a micro hydropower plant consists of hydrokinetic turbines arranged in different array formations for rural power supply. Firstly, let us start with the introduction of the project. For project background, micro hydropower plant is a system that converts potential energy of water into electricity by using of hydrokinetic turbines, and it is also a renewable energy due to open source from the river and also called as clean source of energy or nature. For the capacity of electric, micro hydropower plant can generate less than 100 kilowatt. So, how the hydropower plant was invented? It was started with the vertical set water wheel by Han Dynasty between 202 BC and 9 AD. At that time, to pound and hull grain, split ore and make early paper, they were using trip hammers. These activities was powered by vertical set water wheel. The existing of water is one of the sources that corresponding with re-energizing the economy. Then, Cromford Mill was built by Richard Arkwright in 1771. Hydropower was the energy he utilized to spin cotton and put out of the world's first factory system. Afterward, the turbine technology was growth in the first half of 19th century. Besides, Forneron reaction turbine was built by Benoit Forneron, who is a French engineer. This turbine is capable of producing 6 horsepower. In 1849, British-American engineer James Francis was invented the Francis turbine, which is the world's most extensively used water turbine today. Based on research information, the first hydropower plant has been built to power a single lamp in the Craigside Country House in Northumberland, England, in 1878. The technologies of hydropower plant are widely used until today. Based on observation, there are 3 problem statements that I found. Firstly, rural areas located far from the city and chances to deliver the electricity is quite challenging. For example, if the community live in the rural area that need to be across the river, the supplier need to prepare a lot of things such as water transportation. Secondly, rural electricity systems are typically more expensive to establish than urban schemes. This is because the expense of delivering this service in sparsely populated, distant locations with rough terrain and low consumption. Lastly, the use of small electricity generator in rural areas is at the early stage because not many people can afford it and maybe have trouble in maintenance expenses. The objective of this project are to invent the environment-friendly portable hydroelectric generator that can be practiced in rural areas, and to deliver knowledge on the techno-economic analysis of micro hydropower plant consists of hydrokinetic turbines arranged in different array formation for rural power supply in the future use. The scope of project is to research on the proper definition of micro hydropower plant by using hydrokinetic turbine and application of the hydropower plant in rural areas. After gathering all the information, the specification of the products needs to identify precisely so that during the fabrication of prototype, any unexpected defect and abnormal function can be prevented. And lastly, the product needs to be tested and analyzed to acquire the preliminary result. Due to COVID-19 pandemic, there are 2 limitations of project that need to be considered. Firstly, the difficulties to approach the community in village area in Sarawak to conduct on the survey about the insufficiency of electricity in their area. Then the water flow in rural river is not uniform or steadily, and it can lead to inaccurate data analysis during the testing of prototype. When data analysis is failed to achieve correctly, it will influence the goals of project. For the second part, we will talk about literature review. For previous study number 1, the title of journal is Basic Design Aspects of Macro Hydropower Plant and its Potential Development in Malaysia. This journal was established in 2014. As you can see on the remarks column, this is the point that I took from the journal and insert it on the proposal. For citation number 1, the objective is the operation of hydropower plant based on the level of the water flow that's suitable to generate the electricity and the mechanism of hydropower plants in generating power. For citation number 2, the objective is the explanation about modern invention of hydroelectric power facilities which more effective and the condition of water flow will affect the power generated. For previous study number 2, the title of journal is Design and Simulation of Macro Hydrokinetic Turbine. This journal was established in 2013. Citation number 3 and number 4 was took from this journal. For citation number 3, it talks about the specification of turbine blades is the main source that will influence the efficiency of power generated. For citation number 4, the objective is turbine testing need to be conducted when there is resistance existed in channel to measure the efficiency of turbine. For section number 3, I will talk about the methodology that I use for this project. The first method that I use for the methodology in this project is flowchart of the project progressions. This flowchart starts with the study operation of micro hydropower plant, which means start to learn on how the working system of macro hydropower plant. This will help gain knowledge in elaboration for the topic. Then, identify the basic components that used in macro hydropower plant to determine what component that apply in macro hydropower plant so that have an idea to focus on. At review stage, when the information is not well defined, it needs to redefine from the beginning. If yes, proceed to the next process. The next process is review the existing design of portable hydroelectric generator to obtain some ideas from existing design that's suitable to apply on the prototype. Then, compare the type of turbines and define its advantage and disadvantage. To comparison of turbines is based on the reliability of turbine when rotating. After that, understand the electric current between direct current and alternating current. This understanding is to decide the type of electric current and motor used in prototype. Lastly, create the conceptual design of portable hydroelectric generator. This is to propose on the sketch design of prototype referred to gathered information. At the approval stage, the sketch of design of portable hydroelectric generator needs to approved by supervisor. If approved, proposal can be written. If no, start it into the review the existing design of portable hydroelectric generator again. The second method is mind map of basic components used in portable hydroelectric generator. As you can see in this slide, this is the necessary components that must include in portable hydroelectric generator. Firstly is wiring. Wiring is to deliver the electricity. Second one is turbine. Turbine is to transform the energy of flowing water into rotational energy. And third one is housing. Housing is the casing for all the components gathered. For the water conveyance, it is a channel or pipeline that delivers the water flow. And lastly is the motor. Motor is to transform the rotational energy into electricity. For the last section, I will elaborate on the preliminary result for this project. For my preliminary result, I was proposing to my supervisor that I wanted to fabricate any prototype that related to my title project. So this is my idea, which is portable hydroelectric generator. As you can see in this picture, this is my idea or design for the portable hydroelectric generator. How it works? It works when water flow in through V-shaped panel. It will meet the PVC pipe bowl. PVC pipe bowl is to control the volume of water flow. When water flow in this area, the turbine will rotating and convert the energy to the rotational into the electric motor. The electric motor will convert the rotational energy to electricity. The electricity is connected with the USB port. This USB port is to charge the battery of mobile phone or portable charger, to supply lighting surround, and can connect with a portable fan. So, the water will flow out through this circle panel. So, the specification for this portable hydroelectric generator is the housing is made from plastic and the length is 350 mm, the width is 250 mm, and the height is 150 mm. The targeted power produced is 50 watt to 100 watt. The reason why I propose using two pieces of electric motor is to produce more power into this device. Why I choose the cross-flow turbine design for my turbine is because this design of turbine is more efficient when rotating. And lastly is I will provide one USB port as I mentioned before in this device. As you can see in this slide, I will use this table to record all the data analysis. The data that I need to record are flow rate, voltage, current, and power. This table will be used during prototype testing so that the efficiency of prototype can be determined. For the water flow rate, I will use water flow rate tester to measure the value of flow rate. That is the last section for my presentation of final year project 1. For any question, our panels can contact me through this phone number. Thank you.